Okay, Derek has been an agronomist with the USDA NRCS Plant Materials Center in Aberdeen, Idaho for the last 9 years. His work involves plant materials and establishment technology development for restoration of rangelands and wetlands in the Intermountain West. Please join me in welcoming Derek.
Great, thank you. So, having seen all the talks that we've seen thus far, I can tell wetlands are a big priority with everyone. But I still like them, they're fun. So, for establishing a wetland, this is pretty much the standard protocol. We recommend growing 10 to 40 cubic inch greenhouse containerized plants. Plant them at a 12 to 18 inch spacing, using approximately 25 seeds per plug or per container, which amounts to approximately 19,000 plants from 500,000 seeds, with quite a cost by the time it's all installed. Historically, direct seeding of wetlands has been largely unsuccessful due to a variety of different components. These seeds have some really strange requirements that you have to meet to get them to establish right, and when you add into that the fluctuating water levels of the wetland, it gets pretty complex. And after all the years of research, this is still what we recommend, and it's a huge cost to anyone that's working in wetlands, and we'd really like to get those costs down by finding ways to establish these things by seed. So these people in Southeast Asia have been doing essentially the same thing for thousands of years, establishing rice paddocks. You know, they either grow these plants somewhere else or just take clumps of them and plant them in, just stuffing them into the ground, and it's basically the same thing that we're doing. And so we started looking at rice production as, you know, trying to look into it for different clues or different ideas we could come up with for our wetlands. And a few years ago in Southeast Asia, they started having this idea about using pre-germinated seed, where they would place the rice seed in water for 24 to 36 hours and wait for little shoots to emerge from it. And then they can dry the seed for a short while before the seed actually dies, but just dry it enough to where it's usable, where you can broadcast it. And then they can either just go out and throw it into their paddy or dribble seed it with this little broadcaster, a drum seeder. And I found some quotes from some websites. Direct seeding or direct wet seeding can be followed in all the areas wherein transplanting is in vogue. I like how they talk over there, or how it gets translated to English anyway. And it increases the scarcity of labor and saves costs, which is exactly what we want. We want to increase the scarcity of labor. So one other idea we got from this, something to keep in mind, is their advanced seedbed technology. You know, we go through our wetlands and we treat them in a lot of cases as if they're farm fields. We want to go in and disc up the weeds. We want to pack them down and turn them into an agricultural setting. These guys are out with their water buffalo, or their, this is my favorite, their little surfboard behind a rototiller, and they just muck up the soil until it's just a big muddy mess, and then they seed directly into that. So there's a different way of thinking on how to prepare the site before you seed, and it might turn out to be an important difference. So can we use this rice production as an analog for our wetland restoration or establishment? So one of the first things that we wanted to do at the Plant Materials Center is see if wetland seed would act in the same manner as rice seed. Can we find a way to germinate it quickly and efficiently and evenly, so all the germinates coming out at basically the same time, so that you can use it in these drum seeders or broadcasting. So we looked at several different techniques, and most of our research involved Nebraska sedge, trying to find ways to do this pre-germination. And so here in this chart, the GH is greenhouse and GC is growth chamber. One of the big priorities of our research is we want it to be user-friendly, not just something you do in a laboratory, but we want everyone to be able to do this out of the back of their garage or in their truck, you know, real life conditions. So that's why we did it with both the greenhouse and growth chamber. And something we had seen in the past is that if you leave Carex seed or you know, sedge seed, rush seed in a petri dish, this happens to us all the time. You go out and seed into the little cones, and then you leave that petri dish full of seed laying out on your workbench or on the greenhouse table, and it gets watered repeatedly without any treatment. It will actually germinate and do very well in those conditions. And so we've tried to recreate this, and we came up with this idea of using an aquarium aerator in water. And so warm water, these sedges like to be pretty warm, about 95 degrees Fahrenheit. And we put this little aquarium bubbler in it. And we got these incredible results where after only 7 days we had generally, you know, about 100% germination compared to all these other techniques which were really slow in germinating. So over time you might have something with a really long shoot or cotyledon coming out of it and a bunch of seed left over with nothing germinated at all. So we really like this. It's really quick, it's uniform, it doesn't require any stratification treatment, which is normally what you do with sedges. So this was really encouraging. So we did the same thing. We've got Nebraska sedge here. This is Baltic Rush, same thing. It also worked with beak sedge and water sedge. I have tried this on a couple of different bulrushes and didn't get any good results, but it wasn't a good test, so I don't want to take anything from that just yet. So we want to know how long to soak this. What can we recommend to the land managers? So I measured the cotyledons that had emerged, and I wanted something that was about 0 to 2 millimeters long so that it's still usable in these broadcast seeders and to where it's not so far established that once you broadcast it out, it can't get established. So we tracked these over time and found that between about 6 and 8 days under these conditions, the aerated water treatments had really high rates of germination and had these shoots within 0 to 2 millimeters in length. After you go longer than that, then they get longer and longer and more difficult to work with. We next looked at how long do you have to dry these things before you can use them in a broadcaster or before you can toss them out by hand. If you let them dry for too long, they're going to die. And so with Nebraska sedge, you can see that after just about 4 hours, it really drops down. Baltic Rush was a bit longer that you can let them dry, but there's still dramatic loss in life after just a few hours. So you just want to barely let these things dry out until, you know, they're not clumped all together. But if you wait too long, it's not going to work. So after we developed these protocols in the greenhouse and in the lab, we wanted to take this outside to see how it worked in our constructed wetlands at the PMC. So I wanted to look at traditional bed prep, which is, you know, regular agronomic practices, tillage, packing, water it up, let it dry down so that you can get your equipment on the ground without being mucked in, and compare it to what we call the slurry method, which was what you saw with the water buffalo. Also looked at 2 seed pre-treatments, so the aerated treatment that we developed, compared it to the standard 30-day stratification treatment, which is, you know, the normal recommended procedure with sedges. And then we looked at broadcasting just by hand and compared that to hydroseeding application. One thing to keep in mind is that we only used 2 ponds in this trial. We didn't have enough ponds to replicate the different prep methods. So those comparisons aren't looked at statistically, but just observational. So in traditional bed prep, we tilled it, smoothed it, packed it down, watered it up, and then allowed that water to draw down to where the bed was solid enough to walk on. In the slurry bed prep, we tilled it but didn't pack it and flooded it twice so that when we went in there to seed it, it was still muddy and got muddier as we went. So this is just a comparison of what they look like. You can't tell much from there. In a normal range or agricultural seeding, we recommend that you get your boot print about 1/2 inch deep, and in a slurry bed prep, it was about 2 inches deep. It was pretty soft. For our hydroseeding treatment, we just rented a hydroseeder from a local rental company. This holds 300 gallons and costs $90 a day, which compared to some of the costs of direct or transplants was a pretty good deal. And that covers 4,000 square feet. And it's pretty easy to work with. You can get these at a lot of places. This is the mix we use. So we filled the tank 300 gallons of water, 1/4 pound of seed per mix, and this equaled 150 pure life seeds per square foot, which is a really high rate. I've gotten tired of doing these experiments with the standard seed rate and not being able to find any seedlings, so I put it on heavy just so it would be easier to find. Added this paper-based mulch at 50 pounds per batch and a tackifier at the standard rate of 1/3 of a pound. Here's the per acre equivalents there. So this is what it looks like when you get to go work in this. I didn't have to go lay down in the snow. This was actually a pretty fun day for me. One thing to keep in mind when you're hydroseeding into the water in the wet slurry, one of the concerns was that this would all just kind of spread out and distribute itself. It actually sank pretty well. My plots were marked out with strings tied from stakes on the sides. You can see them just barely. And by the time this was done, you could still make out the plots really well. This is what it looks like hydroseeding in the standard bed. And that's what the traditional prep bed looked like after seeding. And there's a little close-up. So to water this, we used standard irrigation pipe that had holes drilled into it, and so we just cranked it up to where it would bubble just a little bit out of the pipe. We didn't have it on high enough to where it would wash the seed out to the edges.